Session recording. There we go. All right. Just to recap what we have done for the last 2 days. We have started with mechanical drawings. Last year we did it as well, but last year was a lot simpler and the focus was more on drawing the different views. Now that we have practiced different views, what was added this year is that you get a 3D or exploded isometric view of a mechanical component. In this case, it's a pulley. What you also get is an orthographic view of two different views, the front view and in this case, the top view. But they only want us to draw the front view. Hence, I crossed out all the views I don't have to draw, but not so that I can't see the measurements. The scale is also 2:1, so I had to go and multiply all my measurements by 2. Then we quickly planned out our hatching, because if you cut something in half in EGD and you have to represent that on a drawing, you add hatching lines. Think back to when we did civil, the houses. If you show the foundation, you would add symbolic symbols to represent different types of materials, like natural ground, like cement, like wood, etc., etc. Same thing with metal or any type of mechanical component. Yesterday, we started by drawing the shaft, but an incomplete shaft, because I always start with the shaft, but I complete it at the end as well, because that will prevent me from erasing too much stuff at the end. Then I started sliding the components onto my shaft as you would have done it in real life. So it's the bracket, the grub screw, and then we ended with the bush. And I've added the hatching as well. Note that each new component's hatching looks different and drawn at a different angle, and the spacing between them is different as well. The reason we do this is every component is a unique component that has to be distinguished in that way. So you can't have the same hatching for the same component. You just change the angle or the size difference, the gap between the lines. Today we're going to start by drawing the pulley. Now remember, the pulley looks complicated, but if we only, for now, let's just draw the outline and then we'll draw the inside and add the hatching. So we don't have to draw all those lines. All those lines would only be necessary if we had to draw this pulley without the sectioning. But because we cut it, it's quite it's simpler, not simple, just simpler. So we're basically going to copy this pulley. It's going to take a while because there's a lot of turns and bends and angles we have to work with. So let's do this. $64. Just want to check if, okay, 64, the height. Okay, so what I'm just checking, the washer has a height of 66, excluding its base. And this gap here is also the height of 66. That means the washer, the bush, fits in snug inside this gap. So there's not going to be a gap left. So in other words, that's where the hole inside the pulley stops. Now above that pulley, there's a bit of more space left. So I'm trying to figure out what the height is from there upwards. So let's see. What I can also do is I'm going to take the total height and work from the bottom upwards. So it's 90. I need some more center line. Because that's the top part of the pulley. I'm going to work from there and draw downwards. Okay, so what's the length of the pulley or the diameter? It is 316. Divide that by 2 and you get 158.
Sorry to stop, sir, but sir, where did you get the measurement for the height from again?
Good question. And guys, you're more than welcome to, I will try to remember to open the floor up for questions, but you can also ask in between. So the height I got from there. So next to the pulley, from the bottom to the top, you get 90. And I can see if I look at the height of the bush, it fits exactly inside the pulley. It's only this little base that sticks out. So what I did is, if the height of the pulley is 90, I measured from, oh wait, I think I might have done this wrong. Hold up. So from there, above the base of the bush, we measured. I think I made a mistake, so it's good that Hannah stopped me. Otherwise, I would have had. Yep, I made a mistake. There's the height. Sorry, guys. There. Okay, so it's 90 from above the bush. Thank you for stopping me. I almost had to erase a lot of stuff later on. Let's try this again. Okay, so there's the, let's see if I can move this a tiny bit closer. Not closer, just that you can see the whole thing. There we go. I'm going to start moving downwards. So what I'm going to focus now on is that side and this side. So the outskirts of the pulley. So that groove of the pulley on the outside. Let's first work it out. The total space is 48 and the inside is 30. So 48 minus 30 gives me 18. And then there's 2 parts. So 18 divided by 2 gives me 9. Okay, so it's 9. I'm going to darken this part as well because it's part of the drawing. It's not going to be cut away, but I'm not going to go over the area where the shaft is because that will be removed. Now so I've done this part. So this is done. Sorry, I think it's the camera. Sorry, guys, the camera looks like it froze. There we go. So I've done this part, I've done that part. This is done, this is done. Now I'm going to focus on the inside. Now, they didn't give us an angle at which to draw it, but they did give us a size if we look at that part there. Now, let me just figure this out. Where do we get this? I'm just looking for this part there, the distance. Don't worry, we'll get it soon. Oh, it's this. So that hidden detail there represents that groove here. So the hidden detail is 286. So halfway, that's 143. So what I'm going to do is I'm going to put my ruler down on 143. And then 143 and make a mark on the outside. So that gives us a space of 15. So on this side, the same story. Can't see the line. Let me just make it a bit darker. $15. Okay, we're still busy with that groove in the middle. Now, what's the gap? Let's just want to check. Okay, so the gap, I'm looking there. So the gap in the middle is 12, and then we can take 30 again. 48 again. So 48 minus 12 gives us 36. 36 divided by 2, that gives us 18. So the groove starts there, and it has a height of 12. Now I'm not going to do it on the other side again by measuring it. I'm just going to project it. So I'm going to take the points there and put it on the other side. Now, I'm just going to first connect a few lines so we can start seeing the picture itself. Okay, so it's taking form, but we're not there yet. But luckily, it's symmetrical on the bottom side, so I don't have to go and do any calculations again. I'm just going to take these measurements. So that is 8. There, and then the top, this part should be the same. So that is 9 and 9. Yeah, there we go. This pulley, it's starting to look like a pulley. Okay, I'm not going to darken the line at the bottom yet because there's a few things that still needs to happen there. So I'm just going to draw a light line for myself. Okay, there's the outside. Now we can start adding the detail that's left behind on the inside. So next thing I'm going to do is that part there on both sides. Now to work it out, oh, they gave it to us, so we don't have to work it out. It's given to us. It's 26. Now I'm looking for that part there. So we've got that. Oops, you can't see it. Sorry. I'm looking for that part. I have that part. I'm looking for the distance there. So from there to the outside. So let's see. It's this diameter there. So that is 244. Halfway is 122. Just double checking. Yeah, good. 122. them together. Okay, there's the two outside parts of the pulley. Then there's going to be a line here at the top. Just going to show it to you. This line, I'm going to explain to you now where I got this from. Okay. That line at the top stays there because if you cut this pulley in half, you'll still see the back, that ledge, if I can call it a ledge, you'll still see it. This is what you're looking at. It's that ledge of the pulley at the back that's left behind when you cut it. Okay, now I'm going to add the support structures, these structures, the hidden detail parts. They're going to now be added. So it starts there and it ends at the top of where the bush should be, but on the outside. So let me just first add those two parts. Now to work them out, where you get them from is the inside is 64 and the outside is 108. So if I work this out, so 108, my calculator. Okay. So 108 minus 64 gives me 44, but there's two sides, so divided by 2. So 22 and 22. Now let's just connect the brackets. We are almost done. Then at the bottom, these two corners, it looks like little triangles, will also be visible because if you go back to the drawing again, just like there's a groove at the top, at the bottom, at the back, you will also see a part of the pulley. So that's, again, the back that you'll be able to see. Is there anything else I'm going to check if what I missed? No, just need to hatch it. So I'm going to hatch it, and then I'll quickly open the floor for questions about what we've done now in class, or about yesterday. That's also fine. So let's check. I'm going to use this. No, I can't use. Yeah, I'm going to use this angle. No, because that bush is similar. So let's do this. Now the pulley is the biggest part. So I'm going to draw it. This is a better angle. I'm going to draw big spaces between my hatching. Otherwise, I'll take hours drawing it. So make it nice and big. This is cut, but we don't cut it because this counts as a support structure. So it stays just the way it is. So any support structure, bolt, nut, washer, you don't cut it. They also call the support structure sometimes a wedge or a rib, as in a rib that you have in your body. They also call it a rib sometimes. That's something you don't cut or hatch. You cut it technically, but you don't hatch it. Just want to go back to my planning. Yes. There's a support structure at the back. We won't be able to see it because the shaft is in the way. So this is it. I made a tiny mistake, but it's not something that crucial, but I didn't consider that the bolt will probably sit, the nut will probably sit there. So I'll have to erase a bit of these lines. Not a big problem, but I just realized that might be an issue, but we'll get there now with the nut. I'm going to open the floor for any questions. Is there any questions about the pulley or anything so far we have done? The pulley was basically copying what was given, but knowing where to hatch, where not to hatch, and what do you see at the back of the pulley. Okay, is there any questions? I'm just giving a few seconds.
So my only question is Sir gonna post the recording?
Mm-hmm. Yes, I did post the recording. Did you get the recording of yesterday? I think I posted it somewhere this morning.
Yes, sir, but I messed up somewhere this period and I don't know where it is. So I just want to rewatch this lesson so I can fix it.
No problem. Let's really talk about making a mistake. Remember, this drawing is not for marks. This is for you. This is our first drawing for mechanical this year. So this is for you to play around. If you think about any pilot, they have to spend hours and hours and hours in a simulation system to practice. And then obviously, I'm pretty sure, I'm not a pilot myself, but I'm pretty sure they mess up many times before they get it right. And then only do they allow them to go into a plane or step foot into a plane. So it's fine to make a mistake. So guys, if you messed up somewhere, continue with the mistake because that you can learn from those mistakes and to critically look at your own drawing and then tell yourself, okay, yeah, I can improve. This was correct. This was wrong, and so on. So it's a good idea what Hannah said to go back to, so if you messed up, to go back to the video and then compare like, oh, there's my mistake. Something else I want to mention about mistakes. If you're in an exam and there's about 15 minutes left of your, let's say you got 1 hour and there's 15 minutes left and you pick up a mistake in your paper, from my own experience, I would not correct the mistake. Because if you erase something, think about if there was a mistake here and you have to go and erase, you will lose all that work you have done already. So in my experience, you lose less marks to complete a drawing in a test with a mistake than trying to fix the mistake and running out of time. How we mark it, you will lose marks for the mistake, but only once. And then we mark your drawing with the mistake as if it was correct. So we only penalize you for a mistake once, okay, for every new mistake. So in an exam, you have to still decide yourself, is it worth erasing it? Maybe it's somewhere on the side and it won't influence the rest of your picture. Then you can go ahead and erase it. But if it's somewhere in the center, I wouldn't do it. if there's not a lot of time left. Obviously, if you pick up a mistake in the first 5 minutes and you've got almost an hour left, that's a different story. Then you've got time to fix it. So just keep it in mind. Ask yourself, is it worth wasting or losing time to fix the mistake, or is the marks not enough to do it? For instance, every single paper that I give you should have a rubric and must have a rubric. And the rubric tells you which parts of the drawing gets how many marks. So let's say you pick up, there's a mistake, but you will only lose, let's say, 4 marks out of 90. Then I would say you leave it, continue, and see at the end maybe if you can get time. But it's better to lose 4 marks and complete the drawing than losing, let's say, 15 marks because you couldn't complete the drawing, the rest of the stuff. So yeah, you have to weigh the options. Okay, we've got about 6 minutes left. I think what I'm going to do is, okay, let's see at least if I can complete the washer. And then on Monday, to end the picture, I'm going to show you the nut construction. I would rather do it on Monday when we're fresh and back at school. Not physically, I mean back after the weekend. And because this is important, there's a few formulas you have to know. So we'll do that on Monday. So let me just finish the washer itself. So if I look at the picture, the washer fits onto the pulley. So the washer is going to be somewhere there. Not somewhere there, it's going to be on top of the pulley there. So we've got a washer. It has a a diameter of 88. So that's halfway is 44. The height of the washer is 6. Now a washer we do not cut. So what I'm going to do is those 2 lines I just need to remove. So I'm going to take my eraser shield. And just erase it. There we go. Okay, that's it for today. On Monday, when we're back for school and we're fresh, I'll explain to you how to add the nut and the formulas. By Monday, I believe MS Teams should be working and up and running fully. I'll still make use of WhatsApp and my ebooks as backup. But then hopefully on Monday, when we're done in class then with the nut, you're going to send me a picture on either MS Teams or WhatsApp. We'll see what happens. Not so that I can mark it, but I can just have a look at your picture to see if you actually did it. Because if you didn't do it, then you're behind. Then we'll have to make a plan. And B, that if there's a mistake, maybe I can see the mistake and then just tell you, okay, there you made a mistake. Or if you just tell me, sir, I know what the mistake is. I just messed up. Then I know at least, okay, you learn from your mistakes and you'll do better with the next practice drawing. Okay, so that's for Monday. Monday, we'll just have to finish the nut on top, and then that's the picture. We'll just check if we have to, I think we have to add 1 label, and that's about it. So guys, on Monday, we'll see each other again. I'm going to process this recording and send it to you as soon as it's done. And rest well, get enough sleep, and try to shut off from school if you can, to just rest your memory as well, or your mind as well. Thank you so much. See you on Monday.